All right, and let's keep the party going here. Let's try this next one out. As always, we want to begin with the question sentence. So here, if there are 4 left-handed students, what is the total number of students in the classroom? Okay, sounds good. Again, we always want to start off with that question sentence. We have 4 left-handed students. What is the total number of students? Easy enough. So 4 left-handed students, I'll put L for left-handed, blank total. Can we all confirm that the comparison in the question sentence, can we all confirm that we are comparing left-handed to total before we continue? Sweet, excellent, sounds good. So now up next, let's take in the information and really understand if we have what we need or if we need to take a little bit of a detour. Check it out. In a classroom, the ratio of left-handed students to right-handed students is 1 to 3. So if I were to write that down, the 1 to 3, which compares left-handed to right-handed students, do we have what we need? Could we just take this 1 to 3 and put it right there, everybody? Is that all we need? No, it's not. We need more. Like, okay, for sure, yeah, the L for left-handed, absolutely, we could put that right there, 1 for left-handed, but we don't have the total. We know that we need the total here to get this done. That's what we need. So here's how we can get the total in there. Remember, this ratio here, these are parts. A ratio represents the comparison of parts. So we have 1 part left-handed students, 3 parts right-handed students. If we're trying to find the total, help me out, Alec. How many total parts are there in this situation? How many total parts do we have here, boss? Yeah, we got 4. If we add them up, nice and easy, 1 plus 3, that's going to give me 4. And so with that, that's what belongs here. In the ratio or in the comparison that represents the parts, we have 1 part left-handed students, 4 parts in total. So now I know for a fact that I'm going to be comparing left-handed to total, left-handed to total. Now I can feel a lot more confident that once I set this up and calculate, ooh, we are good. And so for those of you who are really starting to pick up on this and are realizing, oh yeah, 1 to 4, this times 4, 4 times 4, that's 16. Hey, right on, my party people, you're doing a great job for sure. So here, let's set it up and solve. 4 to total, 1 to 4. And then we notice we can cross multiply. 1 times t is just going to be t. 4 times 4, that's going to be 16. And we're all good. The correct answer here is A, 16. And look at that. Feeling pretty good. So this is the moment where we're going to now transition into triple ratio questions. And don't worry, it is just as much fun as it is torture. I'll get you through it. We're good. But I want to go ahead and ask you this. Who here, before class started, who here felt like total questions were ridiculous? They were tough. They were absurd. But now you feel that these are absolutely doable. Right on. And again, I really hope that you're going to feel the same way when it comes to triple ratio questions. I really, truly hope you're going to feel the same way. Again, my job is to help you get there, and we have got to, really take in this experience in your own way, what you understand in your own way. All right? So here's how we're going to do this. We still have about 30 minutes here. So here's what we're going to do. I am first going to throw you to the wolves. Okay? I am first going to throw you to the wolves. We're just going to go ahead and try the first one out. And then from there, I am going to walk you through. So here we go. Let's get ready to try this first triple ratio question. And I'm going to show you, as long as you are comparing the same things in the same way, you will be just fine. All right, so let's handle this problem here. We're trying to solve this equation. Now, what you need to know to be able to be successful here is understanding what this symbol means. So those bars, those vertical bars that you see, those are what are called absolute value bars. So long story short, here's the definition of absolute value. Absolute value just measures the distance from zero. Now, let me repeat that because there's a hint in there that's going to make this very, very easy to remember. Everybody, again, absolute value measures the distance from zero. So when you think about it, everybody, what is the one thing in particular about distance? Everybody, if I go 2 feet forward, 2 feet to the right, 2 feet backwards, 2 feet up, 2 feet down, everybody, no matter what, the distance is going to be 2. And that is because distance is always what, everybody? What is distance always going to be? Positive. That's the key phrase there. When you're talking about the distance between a number and 0, you can be, let's go ahead and take a look at this little number line here. And let's say we have 0 right here. We could be at -2 and we could be at +2, everybody. But regardless, if I take the absolute value of -2 versus the absolute value of 2, we're going to get the same thing. Because remember, everybody, these bars right here, they mean how far away are you from 0? That's all that means. That's all that means. So if I go back to -2 or forward to +2, the distance is still going to be 2. That's the idea here, everybody. That is the idea. So here's how we take care of these problems. Here's how we do it. What you can do is you can pretty much take into account 2 possibilities. The first possibility is whatever is in here is already positive. So I can compare the x to 10. Because again, if I throw in 10, everybody, is the sign going to change? You tell me, everybody. If I throw in a positive 10, is the absolute value of a positive number still positive? The answer is yes. The answer is 100% yes. Let's say this was going to 10 all the way over here. The distance between 0 and +10 is still 10. So this is one of the answers that will work. However, there's another answer that's going to work as well, and that's going to be -10. And that's because, everybody, if the value in here is negative, what does the absolute value always do to any negative number? What does it do? Yeah, it makes it positive. Exactly. So we can also have x equals -10 in this problem. Because, let me show you, everybody. Let me show you. Here's the absolute value of x equals 10. Let me plug in x equals -10. Let me show you. If I plug in -10, here's what we do. Everybody, the absolute value symbol, it just makes whatever value in there positive because we're getting the distance from 0. So everybody, the absolute value of -10, it becomes 10. And 10 is equal to 10. So the equation passes, it's good. But the one thing to be successful when it comes to absolute value equations is that you must understand that whatever the input is between these bars, it will become positive once it's all said and done. So understanding that will help you be successful when it comes to dealing with absolute value equations.